We're going to start the unenviable task of the panel after lunch. I know we've planned this exquisitely. We've had the largest panel for the time right after lunch. So, and of course, by this time of day, we're already starting to run behind schedule. So I'm going to implore on our panelists to keep mind of the time. It's indeed my privilege to introduce Steve McClary. Steve is the president of the New Mexico Junior College, who hosts this center with us and is doing a tremendous amount of work to support not only the current energy field and the current workforce in energy and HOBs, but that future workforce as well. So with that, let me turn it over to Steve.
Thank you, Dr. Romero. It's my pleasure to be here. I would ask that our panelists stand as I call your name. That way we can associate who we're talking about. And then I would remind when we get to the question and answer session that you speak directly into the mic so that the audience can hear you. It is our pleasure with this session in talking about the next generation of technologies. Many of the jobs haven't even been created yet that we will try to train and ramp up to meet that demand. These panelists are at the forefront of those new technologies and I think present a great program for you today. First on the list is Robert Brown. Robert Brown is Director, Vehicle Environmental Engineering for Ford Motor Company. He first joined Ford in 1979 as a technical standards engineer responsible for vehicle emissions test cell development. Mr. Brown is a member of the Alliance of Automobile Manufacturers, AAM, the Society of Automobile Engineers, SAE, the Board of Directors for the Coordinating Research Council, CRC, and the Engine Manufacturers Association, EMA. He also serves on the Board of Advisors to the University of California, Riverside's College of Engineering Center for Environmental Research and Technology. Mr. Brown holds a Bachelor of Science in Electrical Engineering from the University of Michigan in Dearborn and a Master of Science degree in Engineering Management from Wayne State University. Mr. Brown, welcome. Our next panelist is John Cogliandro. John, would you please stand? John is currently a senior program manager at the Raytheon Company, where he is working in a strategic incubator called Mission Innovative for Raytheon IDS Division. Over his career, he has contributed to various Navy, Air Force, commercial automotive, and consumer products programs. He is also program manager for Raytheon CO2 Sequestration Technology Project and helps lead several emerging market green technology programs, pursuits, as well as various robotic and senior technologies. He is an internationally recognized speaker and author, having published over 50 articles on technology. Welcome. Our next panelist is Douglas C. Lynn. Douglas Lynn has served as Executive Director of CEHMM. And Douglas, I would ask that you explain that when you do your presentation, if you don't mind, okay? Since 2006, and has enhanced the existing project profiles for the organization, in addition to more than doubling the number of CEHMM staff positions. He originated the applied research component of the Algae Biofuels project and several other flagship projects. His experience includes more than 15 years in the NEPA and radiological environmental sampling and the various disciplines of land management, and has 25 years in experience in agricultural farm and ranch operations. In addition to a Bachelor of Science degree, he has amassed more than 13 professional certifications. Welcome, Douglas. Please help him. Our next panelist is Dr. Michael Young. Dr. Young? Dr. Young is president of the Integrated Environmental Services, Inc., with 28 years of research, teaching, and consulting in environmental protection area. Dr. Young offers a wide array of expertise in RCRA, CERCLA, Clean Air Act, Clean Water Act, and NEPA regulations and project execution. Contributing to the global fight against climate change, IES has partnered in a CO2 reduction technology, patent pending, that converts CO2 emissions to graphite and oxygen. Moreover, the technology can also simultaneously reduce greenhouse gases commonly found in the flue gas of carbon emissions sources, thus significantly reducing the construction cost of new power plants. Dr. Young has a PhD in plant pathology from Virginia Tech. Dr. Young, welcome. Our next guest is Philip G. Harris. Philip Harris is a 30-year veteran of the energy industry. For over 15 years, Mr. Harris was the president and chief executive officer of PJM Interconnection and chairman of the PJM board. Mr. Harris was an influential factor in creating cooperative agreements with the large international grid operators. Tokyo Electric Power Company, North China Grid Company, and Korean Power Exchange, along with Électricité de France. Did I butcher that?
Good.
Was that pretty good? Not bad from a guy from eastern New Mexico, huh? Let me find my place. And the Korean Power Exchange to help further their preparedness to meet the world's rapidly increasing demands for reliable and affordable power. Mr. Harris has served as a member of the North American Electric Reliability Council, NERC, Board of Trustees. Mr. Harris is frequently quoted by media outlets, including the Wall Street Journal, CNN, C-SPAN, Forbes, Fortune, and Time. Currently, Mr. Harris is the Senior Fellow in Penn Future Center for Energy, Enterprise, and the Environment. He also is the founder of GridWise. Great thing about Philip is that he is a native of Lovington, New Mexico. Mr. Harris, it is great to welcome you back here, and he is also a graduate of West Point Military Academy. Please help me welcome Mr. Harris. I think we'll start in the order of introductions, and if we could start with Mr. Brown. I will tell you that Dr. Romero is back here trying to keep us on time, and if you will be sensitive to that, we would certainly appreciate it. Okay? Thank you.
Good afternoon. It is truly a pleasure to be with you today. I must tell you that I am very much impressed, not only with the panels from this morning, obviously our keynote speaker, but also the level of engagement of the audience. It's not often that you have an audience of this size with such keen interest in such an important topic. So congratulations to all of you. What I will share with you today is Ford's plan for a sustainable transportation for the future. I will cover with you the near, mid, and long-term vehicle technology deployment strategy that Ford Motor Company has agreed to and committed to. Also, the types of fuels that we believe will be necessary to align with the vehicle technologies that we plan to deploy in the near, in the near, mid, and long term. And then finally, our policy principles as it relates to effective domestic policy for energy security, greenhouse gases, and climate change. So as I said, in the near term, Ford Motor Company plans to essentially optimize the vehicle technologies for what we call internal combustion engines. In other words, today's gasoline engines that you are probably most familiar with. In addition to making refinements to the powertrain, which includes the engine and transmission, we will also be making improvements to the overall vehicle technology, so improvements in aerodynamics, tire roller resistance, just to name a few, as well as parasitic losses. In the midterm, we plan to increase the volume of plug hybrids that we plan to deploy into the marketplace, as well as the level of battery electric vehicles, full functional battery electric vehicles. And then longer term, we plan to move to truly zero carbon-based technologies such as fuel cells and possibly even greater functionality with respect to battery electric vehicles. Now, key to our plan in the near term is having very affordable technologies. And that is a cornerstone to our strategy. So in terms of improving today's product, we will make improvements to the transmission, where we will begin to deploy increased numbers of 6-speed transmissions with the objective of having 100% 6 speeds in all of our products by the year 2013. 6-speed transmissions offer the potential for a 4 to 6% increase in fuel economy, which on average will have about a 3% effect on greenhouse gases, depending on the level of application, meaning the size of the vehicle, weight of the vehicle. In addition, we will begin to deploy across our entire product lineup electric power assist steering. Electric power assist steering has the potential for a 3 to 5% improvement in fuel economy, and also will enable our weight reduction strategy, which is part of our midterm deployment. With respect to the engine itself, we are very proud of our current engine technology, which we call EcoBoost. It is a combination of direct injection and turbocharging. From our perspective, we anticipate that we will be able to improve fuel economy with this technology and weight reduction on the order of 20 to 30%, depending on whether or not we're talking about a V8 being reduced to a V6 or a V6 being reduced to a V4. Some of the vehicles that will have early application of our EcoBoost technology will be our Lincoln MKS, which is now available in the marketplace, as well as our Ford Flex, which is a crossover utility vehicle. And then coming next year, we will have EcoBoost available in our F-150, which is our high-selling, high-volume light-duty truck. Now, what makes EcoBoost not only affordable but important is that we are able to maintain the performance of a V8 when we go to a V6 with EcoBoost, a V4 when we go down from a V6, or excuse me, an I4 when we go down from a V6. And the primary reason is because of the ability to maintain the torque curve across a wide range of engine operation. And so as you can see from the slide here, the torque is pretty consistent, ranging from about 1900 all the way up to about 6,000 RPM. Now, more recently, we partnered with Magna Corporation, which is a very high-volume supplier for the automotive industry, and we pulled ahead our electrification strategy. In order to do that, we had to make some trade-offs in terms of the work we were doing related to fuel cells. But nonetheless, it was our opinion, Ford Motor Company's opinion, that in the near term, electrification offered through batteries a greater opportunity with more widespread application than fuel cells. So because of that, we pulled ahead and realigned some resources and worked to commit to put into the marketplace a commercial van, battery electric, in the 2010 calendar year, and then following that, a passenger car, battery electric, fully functional. But again, in order to do that, we had to redeploy resources that we had planned for fuel cell development. So, I think most of you are familiar with Ford's SUV hybrids, the Mercury Mariner and the Ford Escape. We were the first in the marketplace with a hybrid SUV, and as you can see there from the fuel economy labels, we're able to achieve a 34 mile per gallon label for the city. With our new hybrid Fusion, we are able to achieve a 41 mpg label for the city operation, as well as a 36 mile per gallon highway number, which we're very proud of. In fact, this vehicle is now the most efficient passenger car vehicle sedan in the marketplace. So what are our plans with respect to electrification? As I mentioned, we will have a commercial van coming in 2010. We will have a small car coming in 2011. And then with respect to our global platforms, where we are a leader in what we call B-size vehicles, vehicles the size of the Focus, for instance, the Ford Focus, we will be bringing over our European-style vehicles, redesigned for deployment within the United States, primarily from a safety perspective, as well as an emissions capability perspective. Now, in order to progress both electrification as well as fuel cell development, it is important for Ford Motor Company to have viable partners. We do not have in-house expertise in many of these technologies. So in that regard, as I mentioned earlier, we've partnered with Magna Corporation from a full functional battery electric perspective. We've also partnered with Southern California Edison in terms of plug-in fuel cell development to understand customer use patterns as well as the interface required for the grid. So, as I mentioned with Southern California Edison, we have a fleet of 20 vehicles that we have delivered to California Edison. In fact, I think we've delivered about 10 of them now, half of that, with 10 more to come. Again, with the objective of understanding the grid interface, what's required to ensure that we have efficient and effective recharging of the battery, because charge time is critical, but also customer use patterns, because there is currently a debate in terms of full electric capability versus what we will call a more blended, optimized design architecture. In the one case, all electric range is important if you're concerned about greenhouse gas emissions, the ability to have zero emissions in the inner city, for instance. In the case of a blended operation, it is more about the displacement of petroleum. And so what you're looking for is the sweet spot design between the size of the battery and the size of the engine. Okay, we were lucky enough to obtain a $10 million grant from the Department of Energy to focus on our plug-in hybrids, and we obtained that again in partnership with Southern California Edison. Now, very quickly, I will talk about what's required from a fuels perspective. In the near term, we tend to focus more on energy security, so we're looking for alternatives to gasoline. In our view, we believe ethanol, E85, is critical in that regard. Now, today, it is corn-based. In the midterm, we expect ethanol to be produced through cellulosic methods. Okay? In other words, moving away from fuel to things like switchgrass, wood, that sort of thing. Longer term, we believe that in order to achieve stabilization in the 2050 time frame, you will need to ramp down fossil fuels significantly and ramp up biofuels. Now, longer term, as I mentioned, fuel cells. While we have decreased some of our engineering research and development in this area, we still have a fleet of over 30 fuel cell vehicles that we maintain throughout the world. Half or a third of those are in California, a couple in Florida, others are in Europe. We also have hydrogen internal combustion engines, which there's a gasoline engine that's been modified to run on hydrogen that we use for shuttle bus purposes. And then we also developed the first plug-in hybrid that utilized a fuel cell and battery. So instead of an internal combustion engine or a diesel engine, this plug-in used a fuel cell to provide electricity to the battery. Now, from a policy perspective, okay, we believe that in order to achieve CO2 stabilization, it's important to have effective policies that are aligned to the objective. So you need to have policies that force the behavior that is necessary in order to achieve the objective. You need policies that encourage consumers to purchase the types of products that are low emitting in carbon. You need incentives to suppliers, OEMs, and others to develop the technologies that are required for zero carbon in the future. But you also need the participation of all of the governments on the local as well as federal level, because we all know that government is not monolithic. So in that regard, it's important to have alignment between the local, state, and federal governments here in the U.S., and then more importantly for climate change globally. So from Ford Motor Company's perspective, we agree and understand that climate change is a serious matter. We believe that we have a role to play in improving the efficiency of our products, and we have a plan to do that in the near, mid, and longer term. But we also believe that it's important for all of the stakeholders to commit and take action as appropriate for their particular sector or responsibilities. So from our perspective, we have a four-legged stool rather than a three-legged stool. We believe that it's the auto industry, fuel industry, government, and the consumer, and that all of us must step up and play our role in order to achieve this most important objective, which is, in our view, stabilization around 450 parts per million CO2. So lastly, drive green, go further, use less. Thank you very much.